Hey guys, so today we're going to talk about the next kind of sequence, but I wanted to do some warm-up questions that had to do with your summations. So now each one of these is an arithmetic sequence. So I can use this rule. I can say S of n is equal to n times a1 plus an all over 2. I can use that equation to help me find these answers, at least for these first two, right? So this one and this one, I'm going to use that equation. So I would say, okay, well, n here, this is 4, that's the one I want to know. And if I plug in 1, if I plug in this first term, 1 times I, or 1 times 3 is 3. And then do plus a of n. So if I plugged in 4, I get 3 times 4, which is 12. So now it's easier for me to do this because it's even. So I'd say 4 divided by 2, that's 2. 3 plus 12 is 15. So this answer would be 30. Okay. For the next one, I could do the same thing because I'm starting at 1. So I can say, okay, well, I want to go to 9. Now 9's not even, so it might be easier for me to do it afterwards. Okay, so if I plug in 1, I get 2 minus 1, which is 1. And if I plug in 9, I get 2 minus 9, which is negative 7. Then I'm going to divide by 2. Well, 1 minus 7 is negative 6. That one's easy to divide by 2, so I get negative 3 times 9, which means I would get negative 27. That's my final answer. Now this one isn't starting at 1, so it's a little different. I'm not going to use this rule, but I am going to say, okay, well, what is 5? If I plug in 5, I get 10 minus 10, which is 0. What's 6? Well, 2 times 6 is 12, so 10 minus 12 is negative 2. And 7 is equal to 14, so 10 minus 14 is negative 4. So if I'm looking at this right, I can say, okay, well, I wanted to go from 5 to 7, and I wanted this to be a summation. So what I'm saying is 0 plus negative 2 plus negative 4, which gives me my answer of negative 6. Okay, so this is summations. You had one like this third one on your first assignment, so I just wanted to touch up on it because I feel like a couple of you are struggling with that. And then number 1 and 2 were what we did on our last assignment. Okay, so that was arithmetic sequences and series. Today we're going to talk about geometric sequences and series. So geometric sequences use ratios. Okay, so ratio means what do you have to do to have a ratio is, well, you're multiplying, right? So if you're talking about ratios or geometric sequences, what you're having is multiplication. Okay, now technically that could be division because division is seen as multiplying by the reciprocal. So multiplying by a fraction. Okay, so it can go up or down by multiplication, division. Just has to be multiplication and division, and it has to be constant. So this first one, 6 times 2 is 12. Is 12 times 2 20? Nope. So this is no, it's not constant. Okay, this next one, well, that one's kind of hard for me to figure out, but I do know this one. I know 1 to 4 is 4 times 4. So if I'm going down, it would be 1/4. Is this times 4? Yep, 4 times 4 is 16. So I can say yes, this is being multiplied by 1/4. So this is my common ratio. Right, so the first couple problems you're going to have on your assignment look like this. I have 3 for you to try. So go ahead and pause the video and attempt these problems. So this first one, I'd say yes, because I can see that each time I'm dividing by 3, So I would say 1/3. This one, I'd say no. Because what's happening is I'm going times 3, times 4, times 5. So this is, no, it is multiplying, but it's not geometric because this is not constant. So it's not geometric. Okay, now this last one is a little tricky because if you're looking at it, 1 to 2, that's times 2. 2 to 4, that's times 2. So you initially want to say yes, but because it's alternating, it's actually being multiplied by -2 every time. Right? So this one is actually not geometric. Okay, so now I would say the reason why it's not constant is because if I'm going to graph this, it's going to look a lot different than if I graphed any of these. Okay, if I graph a geometric sequence, what it looks like is an exponential function. Okay, so if I graphed this, it would be 27, then it would be 9, and then it would be 3, and then it would be 1, and then it would be 1/3. And it looks like that exponential function that we talked about back when we were in the function section. Okay, this function number 3 actually doesn't look like that. It would be -1, and then it would be 2, and then it would be -4, and then it would be 8, and then it would be -16. It would be +32. So it would look something like this. It's definitely not going at a constant rate. So this function would not be geometric, even though it's got that ×2. So up here, when we say the ratio of any term in the previous term is called the common ratio, you are going to want that to be a positive number. So technically that one was not. Oh, this one, number 3, was not geometric. Okay, that was kind of a thing on my part, not yours, if you got that one wrong. All right, now we can write rules for geometric sequences, as well. Gotta change this to my right size. Okay, so a rule for a geometric sequence, it's A1 times R times n minus 1. Okay, so it's actually pretty simple. You don't have to simplify anything because it's already in its simplest form. So this one here, this first term is 5. And I say, okay, well, what's the ratio? What am I multiplying by each time? Well, I'm multiplying by 3 to the n minus 1. So that would be my equation. Okay, so this next one, this one we can see is doing that positive, negative, positive, negative. So we know we're going to be multiplying by a negative. Now it's not technically geometric, but it does follow this rule. So I can say, okay, well, A1 is 88. What am I multiplying by each time? Well, I'm actually dividing by 2, so it'd be 1/2. Because it's going positive, negative, I'm going to have this be negative. Oh. Went back to the thick line. And then I do n minus 1. Okay, so even though this one technically isn't geometric, because it follows the geometric rule, we're going to have some in here. I don't know if I put any in your assignment, though. Okay, I don't want to confuse you. All right, so go ahead and pause the video and try this one. Again, this first term is 3. I'm saying, okay, well, what's happening each time? I'm multiplying by 5, so it would be 3 to n minus 1. Now, if I wanted to find a of 9, all I'd have to do is plug in 9. So this would be 3 times 5 to the power of 8, which would be a really big number. Let me plug it into the calculator again. 5 to the 8 times 3, and I get 1,171,875. Okay, now if I was actually going to write this in the program, I'd write it like this, because it really doesn't like those commas. Okay, so just letting you know, if you have a problem that ends up being a really big number, don't put any commas. All right, now we're not going to graph them, but I do have you having to write out the first 6 terms. So for problems that look like this, where it's just a sequence and the equation, I have it as a matching, because I don't know how you would put this -1 as an exponent into the graph. But for these, because of the nature of the problem, I did have you write out what a of n equals. And the equation looks like this in your program. Blank, blank, arrow, blank. Okay, so what you're doing is you're filling in the equation. So I would say a1, an equals a1, r, we know, r is 2, so I would put 2 here, to the power of n minus 1. So that's what I would put in this blank, right? Now I'm still not actually done, because I still have to find this blank, but I can use this to help me do that. I can say, okay, well, a4 is 12, so 12 equals a1 times 2 to the power of 4 minus 1. So then I can solve this and say, well, that's 2 to the power of 3. And 2 to the power of 3 is 8. So I can just say this is 8a1. Well, now I can solve. Divide by 8. And those both have 4 in common. 4 divided by 12 is 3. 8 divided by 4 is 2. Okay, so I get a1 is equal to 3 halves. So that's what I would put here, 3 halves. Now, if you're going to find the first 5 terms, you're going to notice that there's going to be 5 more blanks. 2, 3, 4, 5. This one says 6, but I think I just did 5. And you'd put them in. You'd say, okay, well, this one's 3 halves. The fourth one we already knew. We knew this fourth one should be 12. So let's make sure it works. Okay, if we're multiplying by 2 every time, 3 halves times 2 is 3. 3 times 2 is 6. 6 times 2 is 12. So we just checked our answer, kind of, and got 12. So good. And then 12 times 2 is 24. So that's how we would do this. Now, you can also get ones that look like this, where you have 2 sequences. And because it follows that same rule, we can still set this up as a sequence of, as a system of equations. So again, this is what it'll look like in your program. Blank, blank, blank. Now, this last blank you should already know. It's n minus 1, right? That exponent is always going to be n minus 1. But we've got to find the other 2 blanks here. So what I'm going to do is I'm going to say, well, 12 is equal to a1 r to the 2 minus 1, which is 1. So I really don't have to write it, but I will for the sake of the problem. Okay, the next one I can say is negative 768 equals a1 to the r 5 minus 1, which is 4. So what I'm going to do is I'm going to divide these equations. Now, technically, if I'm going to divide equations, I'm going to want that exponent over here, the biggest exponent, to be on top. So what I'm going to do is I'm just going to grab this one and move it down. So that way the 4 is on top now. Okay, so I'm going to divide these. Say a1 will cancel a1. And r4 divided by r1. Well, if I'm dividing, what happens with those exponents? You just subtract r3. And then I would type in my calculator. negative 768 divided by 12, and I get negative 64. So now how do I get r by itself if I have a cube? Well, I just cube root it, right? Or to the power of 1/3. That would work too. And I would get r equals negative 4. So then I can plug that back in up here. And I can use this one to help me out. I can say 12 is equal to a1 times r, which is negative 4. So I can divide by negative 4 and get negative 3. Okay, so this is how you'll do it if you are just given two numbers, right? And this is how you put your numbers in the program. Now, I will also say I have these. I still have the 5 blanks. 2 of them are already given to you, right? A1 is 12. A5 is negative 6, 8. Okay. We got that first one. We got negative 3. 12 times 3, or 12 times negative 4 is negative 48. Negative 48 times negative 4 is 192 times negative 4 is 768. So we kind of checked our answers as we went along then, because we had those two that we already knew. Okay, so that's how you'll fill in the blank for those. All right, the last thing you're going to have to do is you're going to have to solve sequences or finite geometric sequences. So finite means that you have an end number, which most of the ones that we've been working with so far do. They have a number up here. They don't have the infinity symbol. That's what makes it finite. Okay, it also has an equation, so you're going to want to write this down. S of n is equal to a1, 1 minus r to the n over 1 minus r. So if I'm going to solve this, I would say S of 10 is equal to a1, which is 4, times 1 minus r is 3, 3 to the power of n, which is 10, over 1 minus r again, which is 3. Okay, so now I can simplify this. I can say, well, clear this. 1 minus 3 to the power of 10 is negative 59048. 1 minus 3 is negative 2. Negative divided by negative is a positive. So I'm going to divide that by negative 2 and times by 4. And I get 118096. Okay, again, this is how you want to put it in the program. You don't want to put in the parenthesis or the comma here. It's going to count it wrong if you do, and I don't want it to count it wrong for something little like that. Okay? So, when do you actually see summations of geometric sequences in real life? This is actually the equation that we use to calculate what monthly payments should be on loans, because it's exponential. So it's kind of really interesting. So if I have a loan with an amount L, so this would be my loan amount. The monthly interest rate is I, that's I. And it's, again, it says in decimal form. T is the term, so how long do you want to have to pay it off? And K is like your N, right? So if I was going to fill this in, if I want to calculate what a monthly payment should be for a 5-year loan of 20 grand, what I would do is I would say, okay, 20 grand on top divided by the summation of 5 years from 1 over 1 plus I, which is 6, so 0.06 to the n, or to the k for this. Okay, this would be what my monthly payment would be. So, first thing I want to do is solve the bottom. This 20 grand is going to stay up here. Say, okay, well, from my equation last time, I know that A1 is the first thing that I've got to find out. So if I plug in 1 for this exponent for k, what do I get? Well, I get 1 divided by 1.06. So I get 0.94. 0.94, that's A1. That's not a 4, that's a 5. 0.94. Then I multiply it by 1 minus r to the n. So what's the rate? Well, the rate is what this equation is, so that's 0.94 to the power of k to the power of 5 over 1 minus r, which is 0.94. So then I'd solve that out. I'd say, okay, 0.94 parenthesis, and then I do another parenthesis for my top. 1 minus 0.94 to the power of 5. Close that parenthesis. 1 minus 0.94. End my parentheses. And I get 20,000 divided by, I don't think I did that right, 0.94 to the power of 5. Is that minus 1 is that divided by 0.06 is that times 9.4 is that 41.69. Okay, so now I would divide these 20,000 divided by 41.69, and I get, well, my monthly payment would have to be $479.73. Kind of interesting, huh? Maybe not, right? I won't have any word problems for you like that. We're going to stick to problems like these. So if you want to go ahead and pause the video, remember you're using this equation. I just want to pull all this down so I can put that equation up here. S of n is equal to A1 1 minus r to the n over 1 minus r. Okay, use this to find these three. Check your answers with what I get. Okay, if I plug this in, I get, well, what is A1 here? If I plug in 1, I'd get 1 minus 1 minus 5 to the n, which is 8, over 1 minus 5. 1 minus 5 to the power of 8, negative 390,624 divided by negative 4. And I get 97656. Okay. Same thing here. I'd say A1 is 6. 1 minus negative 2 to the 12th over 1 minus negative 2. to V6. Negative 2 to the power of 12. Minus 1. Get negative 4097. Divided by 1 minus negative 2 is 3. 6 divided by 3 is 2. 2 times negative 4097 is negative 8194. Okay, this last one, negative 16 times 1 minus 0.5 to the 7 over 1 minus 0.5. So get negative 16. 1 minus 0.5 is 0.5 on bottom. 1 minus 0.5 to the power of 7 is 0.99. Divided by 0.5 times negative 16. And I get negative 31.75. That's how I would do these problems. Again, today's just a video. Tomorrow you'll be doing the assignment. But if you want to work ahead, you can. I hope this was helpful. If you have any questions, feel free to reach out. Have a nice day.